open source software and open science. Well, you might guess from the name that open is in both of them, are a very productive, natural pair, but also a productive pair. I'll think a little bit about why, relative to other fields, adoption has been fairly slow in economics. Still, the dominant programs to analyze data, to model, are still Stata and MATLAB. And how we might change that, and what are my own efforts trying to change that, which includes this course. I'll argue it has a lot to do with how we train students. All right, so let me jump right in. So both have open source and open science have the open in the name. So unsurprisingly, they both share broad set of philosophical foundations, if you want. Most importantly, transparency. They emphasize that. So in open science, that's about sharing data, sharing methods, and the results, really to ensure reproducibility, as we've just talked about, and trust, that somebody has not made a mistake or deliberately made a mistake. In open source software, it's really sharing the source code to allow inspection. And have an example, a very old one, where this is really important. Yeah, but also to build on that. Yeah, like in science, we build the old metaphor of standing on the shoulders of giants. Yeah, and open source software, that's the only way you can do that. Yeah, you can't really build on a compiled code of someone else. They might always change it. Yeah. Whereas if you have the source code, you can actually modify it if the license allows it and build on it. Yeah, just as we may use a mathematical proof that somebody has published, build on it, improve on it, etc. Yeah, then two more aspects are really collaboration, which in open science really tries to encourage the collaboration also across disciplines so that we can solve complex problems. Yeah, and open source software is really built on these collaborative development models. Won't talk much about specific softwares, but maybe one that most of you may know is Git and GitHub, GitLab, which really allows thousands of developers to build on one piece of software from anywhere in the world, of course. And finally, accessibility. Open science really tries to break down the barriers of accessing scientific results. Yeah, and same source software really provides free access to tools so that we have innovation without barriers. What are practical overlaps? Well, the most important Marianne already mentioned is really reproducibility. So open science relies on open software so that we can ensure that experiments and analysis can be replicated. Yeah, whereas open source software provides tools, platforms. Think of R, Python, within Python, Jupyter notebooks, which are really widely used in the research. And yeah, licensing is more an issue in open source software, of course, though you can think of open access as being sort of the same idea, that otherwise you have a closed license. That is, you have to pay in order to read an article that someone else has written, but that's for another occasion. And of course, with the developments we have here, at least within Germany, that most of the research is actually being published open access now. And finally, that, what we would call transdisciplinary research, this community-driven development has also been a big thing in open source software, that you really take the needs of people who want to use the software very seriously. All right, I would really claim that if we're serious about open science and we're doing empirical research, you need an open source software stack. So it's very easy to introduce errors, even for moderately complex computations. Errors could be plain bugs in your code. You just mistyped the variable name, or you swapped the order of calculations, divided by the wrong thing. Happens to all of us. We're humans. Happens to AI if you let that code too. So we just make errors. That's just a fact of life. And it's important to be able to inspect that later on. Yeah, taking invalid shortcuts. Often computations take a long time. And we may think, okay, let's do a shortcut, let's do that. And in the end, it's invalid. That'll be my example in a sec. More subtle thing that we've seen a lot in what we've been doing are computations that have poor numerical properties. Yeah, so for example, in the classic derivation of the OLS estimator, you have beta equals x prime x inverse times x prime y. If you just write that out and have a fairly large dimension of your regressors, and you're maybe not the most informative regressors, some of them, the numerical properties of that inverse will be very bad. And you will get very weird results if you're unlucky. You will never see that. But there are ways to solve that system of equations without doing the inverse explicitly, which are numerically just much more stable. The issue is, why can't we say, okay, it's open science if it relies on closed source software, on compiled software, that it's hard or impossible to track down any of these when the code is a black box. If you write your Stata script, but sort of whatever Stata Corp has done, or MathWorks have done, if you're using MATLAB or whoever, might not be doing the exactly right thing. And the example I love for that is from my own days as a student. So Florian Heiss, who was a couple of cohorts ahead of me, now an econometrician at Düsseldorf, had this nice paper in the Stata journal where he, after a long, long time, I sort of remember him doing parts of that, of trying to figure out what was going wrong numerically with these estimates from Stata, found out that they baked in an assumption in the nested logit estimator that just didn't make any sense. Yeah. So of course, this being the Stata journal, the abstract is much nicer than it should have been. Yeah, because basically it says, look, there's two major variants and only one makes sense in almost all situations. Essentially, that was the standard. Yeah. Everybody would assume you have what he calls the random utility maximization nested logit. That should have been there. Yeah, but they used a different variant with the shortcut, which just has some implicit assumption which don't make any sense. All right. Yeah. If we think at a broader level, then open source software really is incredibly successful. Yeah, you might know this. I don't know, I need to get a little bit out of here. Oh, let me just disappear for a sec. Yeah, let's sink in. Yeah, but this really says, look, essentially anything you see on the web at some level is powered by open source software. Yeah, all the server infrastructure all runs on Linux. There is no proprietary software, and there's simply no way to get something as complex as the internet running with large chunks of proprietary software. Yeah, so it's really an incredible success story since it took off in the early 80s. We're not quite there yet in open science, I'd say, and certainly not in the usage of open source software in economics, even though I've just claimed that there's huge benefits to it. So why is that? Yeah, so first state the fact. Yeah, so the adaptation really is slow relative to other fields, especially if you compare it to machine learning, how fast that has obviously evolved in the last 10 years or so. Yeah, that's all essentially Python. Yeah, and sort of libraries based on that. And it's all open source. Yeah, maybe some models of companies like OpenAI, Anthropic, etc., are not open source. Yeah, but the basic building blocks of all these techniques are all open source. And without that, this would not have evolved at the speed we've seen recently. Yeah, still in econ, if you look at applied micro, then Stata is dominant. Though R and Python are slowly but steadily gaining ground. Yeah, MATLAB still probably is dominant in macro research. Yeah, there Julia is still slowly gaining ground. Why is that slow? Why is that so slow relative to other fields? Well, it's of course speculation. I can't give you a clean experiment. This is sort of my own observations. Yeah, first of all, us being good economists, we believe in the division of labor. Yeah, so we're doing the research, we're doing the economics. Someone else can code up the estimators. My own view is, unfortunately, that doesn't work most of the time because at least if you're doing cutting edge research, often the two are very much intertwined. Or cutting edge methodological research, I'd say. Or where economics are not generic enough to sort of be implementable in something like an OLS estimator or an asset logic estimator or a two-way fixed effects estimator or something like that. Yeah. Maybe more importantly, I'd say that there's hardly, and unfortunately that's still true, not only 15 years ago, as Marianne just alluded to, there's hardly any systematic training in programming and computation in our curricula. Yeah, and something like here you have the theory for IV. Now run this data command implementing the IV estimator on a data set that I've cleaned for you. That doesn't quite count as systematic training in programming or computation, trying to find out trying to find out bugs, etc., etc. Yeah. So because of that, yeah, almost everybody I've met really knows just the little bit of programming to get them running with what they need for their own research. Yeah, so if you're at my age or beyond, or also 10 years younger, there simply is hardly any time to invest in the switching costs to another language. You simply can't find the time. No way. Yeah, that's very different if education like people in physics would have. Yeah, where you have the basics, and I don't claim I have them. Yeah, where you have the basics really of how software works, how computers work. Yeah, and then any language is sort of the same. They just use slightly different syntax. Yeah, far too few people gain that level of understanding of computers in order to still make a switch later on in their careers. Yeah, of course, there's who still write code in Gauss, which, having looked at some names and faces before, most of you probably don't know anymore. In the 90s, it was a big competitor to MATLAB, but after that was completely surpassed by that. And it had a good maximum likelihood routine, which is why many economists ended up using it. All right. Yeah, so we have a very slow moving ship because of that, I think. Yeah, once you're with a language, you stick with it, you train your students in that, and that's it. What are some glimpses of hope? Well, first of all, it's already a big advantage that, and I guess Lars Willhuber was here before me. Yeah, we have these policies by journals now that require reproducible results. That was, of course, triggered by some big scandals in the 2000s, where very well-published papers were not reproducible. Luckily, we've moved past that one. Naturally, they won't say, okay, it has to be all an open source stack, but the philosophy is right there, and I think we're pushing in the right direction there. Same when it comes to funders. Yeah, for example, the DFG is doing, requiring these open science standards and really asking questions for big things. So we have the evaluation of our CRC coming up this week. We're thinking hard about ensuring these standards can be held up. The other thing is the adaptation of tools like machine learning or AI tools in general, which are essentially all in Python and R, and there's no way for, as I've claimed before, for a company producing closed source code to keep up with those developments. No way. Yeah, so as these methods penetrate into economics, we'll see more and more adaptation naturally of the languages they're using, which is predominantly Python, but also R. Yeah, and finally, I have very ambivalent feelings about that. Yeah, it's also the vibe coding thing where you don't do any coding anymore yourself, but basically you tell your AI assistant, this is what I want, please produce some code. This works much better, of course, the larger the training base for code and the amount of Stata code or MATLAB code that is being written and out there to train these models on is tiny relative to the code that is there in Python or R or any other open language, most other open languages. So these things will tend to work much, much better for these more widely used languages. Yeah, this said, I don't think it's for research very good idea unless you have very standard things that you're doing and your innovation is purely in, let's say, your data that you can access, but otherwise your way to analyze the data is very standard, then this may work. If you have some sort of quirks and methodological innovation in your data, I've so far seen very few examples of where students came up with reasonable AI-generated code. In the last iteration of this programming course, some people were very unpleasantly surprised because they hoped that vibe coding would get them by, but we're not there yet. Maybe in 3 years, I'll look differently at that. Yeah. All right. Yeah. I said I'll close, or the second part will be some examples of what we've been doing here. So with a wider group here with my former colleague Philip Eisenhower, who then moved to Amazon. Maybe not the most open choice you can do, but was definitely good for him. He likes it. Yeah, it's the open source economic groups here in Bonn. So that's still lots of students, former students who are part of that. And what we're doing, you could think of in three parts. Yeah, one is training. Yeah, this is the mostly this effective programming practices for economists course that we've now talked about a couple of times already. And more recently, we changed the curriculum in our bachelor's completely. And in the first term, people now get a light version of that, which works in Jupyter Notebooks and is called Applied Data Analytics. So essentially, it's trying to do descriptive statistics, some interpretation of economic statistics, of behavior of people, but applying it directly on data. Yeah, so not the dry thing. Okay, here, this is how a variance is defined. This is how you get at the standard deviation from that. But really, here's a data set, compute that, and now think about what that uh, might mean and how you might interpret it, what it might be useful for. So the first iteration naturally had some hiccups, but went quite well. I'll talk a little bit more about the effective programming course in a second. The second big area you could think of as sort of workflow-related tools. So a former student has written this very nice tool, PyTask. I'll come back to that a little bit later. And we've set up partly, or I actually came up with them as part of the effective programming course, sort of a set of templates that you could use in order to kickstart an a project that you want to be reproducible. And finally, the last and probably biggest building block is actual software you could use in research. Yeah, the one that's closest to my heart in a way and sort of ties everything together is pylcm. So LCM for lifecycle models. And then we have sort of the outer shell around that in order to estimate these models. We've come up with a software package that's now continued to be developed by my former student Janos Gabler and Tim Menzinger, who both work for Applied AI now, which is called Optimagic, and as a sub-package, Estimagic, which really gives you lots of tools in order for numerical optimization, but also for the estimation of these structural models. So by maximum likelihood or the method of simulated moments, I'll give an example of that later. Yeah. And second was part of my work with my still colleagues at IZA, an open source taxes and transfer simulator called GETTSIM, the German taxes and transfer simulator, which you could use to plug into models that you have here for life cycle decision making. Yeah, think of retirement decisions, think of how long to stay out after childbirth, yeah, and how to divide that up between parents. That's of course shaped by the taxes and transfers environment, and that's what GETSIM tries to do, namely provide a function that returns the budget constraints given state variables. All right, so let me start with the programming course. Yeah, so as Marianne said, it's a graduate course, and mostly trying to get people up to speed in order to do reproducible research, which I think really is a matter of teaching them some good practices of software engineering. Yeah, once you have those and you know how to structure code nicely, how to debug code, how to minimize state, yeah, how to divide it up in a way that you can have small chunks that you can focus on while not losing track of the big picture. That's half of the thing. Yeah, then debugging becomes much easier, and other people looking at the code have a much easier time. we do have some components, especially with Janos and also Tim getting so deeply into sort of this numerical optimization part on sort of what is more would have been traditionally in a programming course. So algorithms for optimizing, etc. That's also some part of it, but I would say the most important part is really okay. Um, most of it is really about software engineering and reproducible research. Yeah. Yeah, as I said, the current version we have is has been developed by Janos, myself, and Tim Ensinger. Yeah, so I have the link here. Want to look at it. The way it's set up, so the site, which is all available and all the sources are on GitHub, of course, is that it's built up like a textbook. Yeah, so you see here on the left-hand side are chapters. Let me, for example, look at Git, or maybe that's not the best example because there's so much material on that 80% of that we just link to other videos. But yeah, take software engineering, maybe. Yeah, there's lots of things here from naming stuff, having pure functions. Maybe take that one, and then it would all look like that. Yeah, so you have some learning objectives, then you have a video, and then you can check whether you grasp what we thought should be the most important parts via this little quiz here. You'll see that the topics here would be far too long for any individual lecture. Yeah, so I'm glad that back in the day, your student or colleague, Marianne, took away something useful from the course, but from a didactical perspective, it didn't make any sense. Yeah, I plowed through so much material in a short time that probably after 5 minutes of lecturing, I lost most people, even though there was a big chunk on then working on examples at home afterwards. But probably the lectures were pretty useless. I hope that has changed now. And the idea here is that this is sort of like a reference. And then in a given course, either semester long here in Bonn, or I've given multiple block courses also together with Janos and Tim at various institutions, we would pick for one lecture. Now let me go back to Git. Yeah, you'll see there's like 10, 12 different chapters, but we would start in one lecture maybe only with the first 5, then do something else. Yeah, if people practice that at home and in the next lectures, and then only 3 weeks later come back and do 4 or 5 more of that. Yeah, doing everything in one block wouldn't help at all. Yeah, so this here at the same time when you go back, yeah, you don't want to remember, oh, okay, yeah, when did we do that? Yeah, in week 5, maybe we did some advanced Git. Maybe it was week 6. Yeah, then that's not the right way to think about referencing. Yeah, so that's why this is structured like a reference book, so that you have really a quick way of finding what you use. Yeah, but at the same time, you have a companion site then for individual courses. Probably not so relevant for this crowd here, but if you or your students or whoever has a need, yeah, I hope this part is also useful material. Yeah, so the videos are all pretty short, 3 to 10 minutes usually. So they should be easily digestible. Maybe for the TikTok generation, we need to cut them down even further. But for the moment, it seems to work. Right. Yeah, that's the course. How about the workflow tools? Oops. Click in here. Yeah, so these templates for reproducible research, you'll find them here on the GitHub site. Oh, that's the documentation. And then you could go here and get the source code and adapt it to your needs. What's the idea behind that? The idea is really, okay, now we're teaching all this. Do we really want that? Tend to have about 50 students each iteration here in one. That everybody comes up with their own implementation of how a project might start. They all look pretty much alike. And that's what this site tries to do. It tries to give you the reasonable structure for how a Python-based empirical research project may look like. And then you would start from that, do some search and replace in the entire code base for placeholders, replacing them with your name, with the title of the project, etc. And then you would have the shell of it already running with some example of why the different steps are there. So it's structured that in a first step, you sort of clean up the data. In the second step, you run your core analysis. And in the third step, you then format the results nicely in a way that they can be put into a paper and or presentation. So this is all powered by PyTask, which has been written by a former student, Tobias Rabe, which builds a directed acyclic graph that has scripts or Python code and sort of data sets, typically as nodes, and then different tasks as edges. So that you can think of the entire pipeline of your project as sort of data flowing through that. There's other things around that are doing similar stuff. Most widely used a while ago was Airflow, which is a very similar thing developed at Airbnb. The difference really is that, at least for the moment, still for most econ research things, we're really working with files on disk. Whereas most of the tools that you find for other purposes can't work with files on disk, but will work with SQL databases or the like as the primitive nodes. The important thing is that, maybe let me show you a graph where you won't see much, but at least you see that it's a graph. So the first time you run it, so at the bottom here, this is how things flow from the original data to the finished paper to the finished presentation down there. The first time things run, everything has to run from the top to the bottom. But after that, if you change, say, only some code for a plot, which is right here. You run PyTask again, and we will realize, okay, I don't need to do anything up here. I don't need to do anything on the right part of the graph here. The only thing that has changed is this one. So let me run that task again, reconstruct this figure. If that figure has truly changed, then I also need to recompile the paper, and I need to recompile the presentation. So you save a lot of computing time, which can be prohibitive if you have large data sets or complicated estimations, etc. Oops, what has happened here? Oops. Sorry. Okay. There's some similar projects around. So Tobias has this cookie cutter PyTask project, which is more geared towards a software-based or software projects slightly. And then Alpha Tural recently has come up with one, which is also fairly similar, also based on cookie cutter, which is a templating tool in Python, which uses a slightly different set of tools. So if you don't like PyTask, then maybe that's for you. So that's also very good, very similar ideas. Right. Okay. Last building block, and of course, the one that's in a way closest to my heart as a researcher is research software. So the things that interest me the most these days are decisions individuals take or households take over the life cycle. Yeah, so anything where parts of the consequences of the decisions accrue only in the future. You know, classic cases would be the decision when to retire. Now, of course, you're retired when you retire today, you're retired next period, if it's an absorbing state in your model. But if you don't retire today, you have the option to retire next period, the period afterwards. Yeah, you accrue less pension benefits if you stop working earlier. So that's in most systems, like the German public pension system, means you have a very different income stream for the rest of your life. And somehow you need to come to a decision how to trade off utility and consumption over time. Typically, these models have required running or programming for 3.5 years before you get your first result out. Because you have to do everything yourself, from preparing the data, very obviously, but coding up the entire model, coding up the solution, strategy, coming up with your own implementation of some simulation of moments, etc., etc. Yeah. We try to do that in a way that hopefully it will be a matter of a slightly more complex specification of a typical regression model. Yeah, so the idea is that as a user of the package, as a researcher substantively interested in one of these questions, you specify this state of states by choices, or the states by choice space. Yeah. And then things like utility functions, like transition functions, yeah, sort of, can we go back to work after we retired? Can we separate the labor supply decision from the benefits claiming decision? Yeah, very important task these days when you think about Germany, where they're discussing things like the Aktivrente, which is exactly that. Yeah, where you try to get people who have started claiming their social security benefits to keep on working or to return to working. Yeah, so if this, what we ordinarily call retirement, which we think of as the joint decision of starting to claim your social security benefits and stopping to work. Yeah, we have two separate decisions there. Yeah, these would be transition functions. Yeah, whether you can go back to work or not. It's obviously a modeling decision. Yeah, we specify the environment. For that, we will be able to use GETTSIM. Not quite yet, but in a month or two. You'll need to have an initial sample. Yeah, so we call the initial conditions then. Yeah, what's the population that, say, starts out at age 50, and then you model their remaining working life. And then you will have parameters. Yeah, let's call them preference parameters, but could be broader than that. Yeah, which govern the choices. Yeah, what's your preference for leisure relative to consumption? What's your risk aversion? All things like that. Yeah, these will typically be the parameters that will be optimized over. Yeah, like you come up with the beta parameters in your OLS estimation or IV estimation. Yeah, you come up with the preference parameters that best explain the data. Yeah. And for that, I'll come to. Those will typically be optimized over, and we'll have those that best explain your data. And for that, we'll have be able to use a tool like Estimagic, which I'll come back to on the next slide. Yeah, so what will pylcm do? Yeah, we'll first solve the model backwards on a grid, starting in the last period. Say you allow people to live up to age of 100. Some mortality probability each period, and then you solve it back from the last period. where the only thing probably is, okay, let's consume my remaining wealth or whatever I get out of the social
Yeah.
security system.
Excuse me.
Well, then,
Um,
yep.
do you think we can finish in about 3 minutes? I mean, we started later, so we
Yeah,
can
yeah,
finish a
I'll
bit
manage.
later. Yeah,
No
okay,
problem.
thanks.
Yep. We'll then simulate the decisions forward for the initial sample, starting from the initial sample where say everybody is age 50, simulate their remaining life until age 100, and then return the data set of simulated decisions and states. Yeah. And that's where something like STMagic comes in. Yeah. So it will basically be a wrapper around LCM, yeah, which returns a function which you can call many, many times. So in the above example, you would simply call estimate MSM for method of simulated moments with a guess of the parameters that's required by your pylcm model, a function that's computing a weighted difference of the moments between the simulated data and the observed panel data. You pick one of many, many available optimization algorithms. So I won't claim any um, credit for that. That's all Janosch and Tim and collaborators. Yeah, uh, which is what Optimagic does. Yeah. And then you obtain the parameters that best explain the data. You get standard errors right away, and you even get statistics on robustness and sensitivity to some moments. Yeah, so hopefully makes life much easier. The last building block specific to Germany here that hopefully makes life easier is GETTSIM, which stands for the German Taxes and Transfers Simulator. Actually started as a simple port of the tax and transfer simulator our colleagues at IZA had coded up in Stata, which is not good, not useful for that purpose. Yeah, simply we wanted to port it to Python, but it became a multi-year, still ongoing effort. So I basically spent the last uh, 3 months with my student, Marvin Immel, Tim Mensinger, Maximilian Jahn, I think Felix Schmitz was here on that. And we're almost at the point where it really should become very usable for many people. It aims to provide a flexible, transparent depiction of the current and past state of the German taxes and transfer system. Should be usable both for structural models like pylcm, where you want to optimize over things, where you need packages that really run things fast, like JAX, which powers much of the AI models. You don't want things like rounding, which you all know from your tax return. You can round this number down to the next full euro. Um, you don't want that because it would mess up your numerical derivatives. But at the same time, you want to be able to use it for policy simulations. So, for example, we've consulted for the last government on the implementation of the Kindergrundsicherung, what the results of that would have been. So there it has proven very useful together with models that our colleagues at E4 and ZEW had. Yeah, at the same time, it should be usable for newcomers, so hopefully we'll get that one right. And there's similar efforts on an international level. So from France, it's OpenFisca. And then in the US and UK, you have Policy Engine, which is actually a fork of OpenFisca, which has similar ideas of really doing it out in the open. Right, let me finish up. Yeah, for the own stuff that we've seen, the lessons really, my lesson is the opportunity cost for putting all that together was really high. In the sense that I certainly would have published more papers had I sort of focused on the bare minimum of coding that I could have gotten by with, but I think it's really worth it. Yeah, when you develop open source software that hopefully others can use and that you can reuse, this modular structure that we have in all these projects really is key. Yeah, because the science frontier is ever changing, so you don't want to build a monolith that can't be run again. So some ideas of this meta programming, these DAG-based pipelines really are crucial. Yeah, one thing that we hope in the future is get a larger community involved. So if you have ideas of how to do that, they're very welcome. At a broader level, beyond my own little part of the world, yeah, yeah, let's finish up with what I started out with. Yeah, definitely open science, open source software, very, very productive pair. Open science is gaining traction in econ, but the incentives here are certainly much more complicated than for open source software, simply because so much credit goes to the ideas relative to a very good implementation. Yeah. So it's very hard to develop these ideas out in the open without anybody, yeah, sort of being able to claim they came up with the idea first. There's less of a problem in open source software where it's really about having a usable piece of software and not about having the idea of how it could work possibly. Use of open source software in economics is gaining tractions, but there we definitely have a long way to go. Yeah, I think the lack of good training is a key obstacle here. I've shown some examples of training, of how to use software, how to write software, although this is in the big set of econ research, admittedly a fairly niche field. So the question is when we'll see something like the big frameworks in machine learning / AI, like scikit-learn, TensorFlow, more recently PyTorch, for applied econometrics. Let's see. Let me finish with a shameless advertising part. Yeah, so maybe it'll be some graduates of the Bachelor of Science in Econ and Computer Science that we're just getting started here. So hopefully we'll have a first cohort that gets started on that next year. Very excited about that one. Thanks for being here. Enjoyed it a lot.